Hi, I'm Michelle Warman, Fruit Extension Specialist at the University of Missouri. In this first session, I'd like to begin by briefly discussing the hard cider industry, followed by cultivar selection, and then planting and growing apples. Let's begin with why you might consider growing apples for hard cider production. Apples have been grown in Missouri since the 1700s. Today, there are around 50 apple growers in Missouri, with some selling for the wholesale market and others selling locally at farm markets. In the past decade, there has been a resurgence in hard cider popularity. Currently, it is estimated to be a $1.5 billion industry. In 2020, there were about 910 cider producers in the United States, and there are about 20 producers in Missouri. Two different types of cider can be made. Sweet cider is a non-alcoholic beverage made from fresh pressed apples, while hard cider is produced from apple juice that undergoes fermentation and contains about 2 to 8.5% alcohol. Ciders can be made from just one apple cultivar, but usually juice from a blend of 2 or more apple varieties results in a more complex flavor. The top 5 apple cultivars sold in the United States are Gala, Red Delicious, Granny Smith, Fuji, and Honeycrisp. Since these apples are primarily eaten fresh, they are known as dessert apples. All of these cultivars can be successfully grown in Missouri for the fresh market, as well as for hard cider, except for Honeycrisp. When Honeycrisp is grown in our warm climate, the fruit is often unattractive as a dessert apple. But because the fruit appearance is less important with hard cider, it can be grown for this use. Although Jonathan apples are not as popular as they used to be across the United States, they are still a Midwestern favorite and are grown here. Even though there are many excellent apple cultivars available, consumers are always looking for something new. Unfortunately, the only university breeding programs left are at Cornell, Minnesota, and Washington State due to the high cost of running these programs. Because of this, most new cultivars are patented and sold as club varieties, which are grown by club members only. In a blended cider, most of the juice is usually from dessert-type apples. To add a greater complexity of flavors, juice from a cultivar with a high tannin content may be added, but usually only about 10% to 20% of this juice may be used in the final blend. These apples are known as spitters and would be grown only for hard cider, not as a fresh dessert apple. Thus, I wouldn't recommend planting high tannin cultivars unless you plan to use the juice yourself or have a buyer in place. Currently, few producers are growing high tannin cultivars in Missouri as trees are in short supply. Due to the high demand for high tannin apples, producers who currently grow these cultivars should be getting a premium price for them, compared with dessert apples. The hard cider cultivars Hughes Crab, Kingston Black, Reine de Pomme, and Harrison are very susceptible to the bacterial disease fire blight. If you have an outbreak of this disease the year of planting and do not use appropriate control measures, you can lose entire trees. In early trials, Daubonnet and Porter's Perfection have shown promise. Hard cider cultivars are often classified by their percent acid and tannin content, which you can see here. The higher acid content apples are classified as sharp or bitter sharp, whereas those with lower acid content are classified as bittersweet or sweet. They are also subdivided by their tannin content. So if you see an apple described as in one of these categories, it gives you an idea of its characteristics. Most high tannin cultivars are very old and unlike new ones, they have not been bred specifically for disease resistance. The dessert-type apples are generally low in tannin and may or may not have low acidity. If you want to grow your own fruit, remember there's a limited supply of hard cider apple trees. Not all nurseries offer hard cider varieties, but many are ramping up their production. Therefore, it's important that you order your trees at least a year before you intend to plant them to receive the cultivar and rootstock combination that you desire. The rootstock for apple trees is important because it determines the tree size, the spacing needed in the orchard, how soon the trees begin to bear fruit, and disease resistance in some cases. The general rule of thumb is that the smaller the tree size, the more precocious it is, which means it starts producing fruit in the second or third season after planting when using the most dwarfing rootstocks. The actual tree spacing on a particular site is determined by the soil type and texture, and the way the trees are trained in the orchard, which we'll discuss in a moment. The rootstocks pictured here, from the M9 size to the G30 size trees, would require a tall 10 to 12 foot stake and or wire to support the trees. Also, on many sites, trees on M7 require about a 6-foot stake to support the trunk in the early years after planting. Also, the smaller the tree, the more trees per acre can be grown, and the more intensive management and cultural practices are required, with greater attention to detail and at a higher cost for orchard establishment. Rootstocks with the letter G are from the Cornell Geneva breeding program and are resistant to fire blight disease. But the cyan variety above the rootstock union can still become infected with this disease. As I mentioned before, it is imperative that you order your trees at least a year in advance. Also, not all apple varieties are grafted onto every rootstock. For example, a nursery may only graft Daubonnet on G11 and no other rootstock. Dormant trees from the nursery are usually planted in late March to early April. Large trees on an M7 rootstock are usually trained to a central leader system at relatively wide spacings. With this system, the idea is to develop a tree that is pyramidal shaped with the broadest part at the lower part of the tree canopy. When the trees arrive from the nursery, remove all the side branches that are less than 18 inches above the graft union. If the tree has 3 or 4 good scaffold branches spaced along the main trunk, they are left, but extra branches that are growing upright with narrow crotch angles are removed. If you need to stimulate a strong central leader on the main trunk, it can be pruned or headed back about 10 to 12 inches above the uppermost branch by about 1/3. In early June, clothespins, elastic tree bands, or spreaders are placed between the side branches and the main trunk to increase the branch angles to 50 to 60 degrees to strengthen them and prevent breakage in later years when they produce apples. The next year, during the dormant season, select 3 to 5 strong permanent scaffold branches that are evenly distributed along the tree, both radially and vertically, to get good light distribution throughout the tree. Do not head back or prune back the central leader. In the third year, head back the central leader to 1/3 of the previous year's growth. Thin out overly vigorous limbs and side shoots that overlap other branches or have become crowded. Usually the tree will start to fruit in the 4th or 5th year. During this time, And during the life of the tree, it is important to maintain a strong central leader and remove unnecessary lateral growth. Once fruiting begins, maintain a good balance of foliar growth to the number of apples on the tree. For more detailed instructions on this training system, Pennsylvania State University has an excellent guide at the site listed here. For trees on M9, G11, G16, and other dwarfing rootstocks, there are several training systems that can be used, including the tall spindle and the vertical axe. For cider apples, where fruit appearance is less important, I prefer the vertical axe system, which requires less labor than the tall spindle. But if you want to grow more trees per acre, maximize your crop yield, and can afford the higher startup and labor costs, the tall spindle may be preferable. For the vertical axe system, basically you have a tree stake with one or more wires between stakes, and the trees are eventually shaped in a narrow, pyramidal form with short lateral branches that are renewed. In comparison with the central leader system, vertical axe trees are shorter. They begin fruiting in year 2 or 3 after planting and have higher fruit yield per acre. However, the vertical axe has a higher initial startup cost than the central leader system due to the higher number of trees per acre, the cost of stake and wire, and an higher labor cost. Depending on your soil type, trees are spaced 5 to 7 feet apart in the row. The between row spacing depends on the size of the equipment that you're using to spray, mow, and for harvest. With the vertical axe, it's important to stake the main trunk of the tree immediately after planting and tie it to its support. If the trees do not have a strong leader, it can be headed back to a height of 28 to 30 inches, or about 10 inches above the uppermost branch. If you get a nicely branched tree from the nursery, the leader is not usually headed back until the 3rd or 4th growing season. Lateral branches are spread to form wide branch angles with spreaders, elastic bands, or tree weights in early June. During this growing season, remove 2 or 3 new shoots that begin to grow below the terminal growing point of the leader to make sure it develops strong, dominant growth. The next season, or in year 2, when there is about 3 to 6 inches of new growth developed on shoots on the top half of the leader, pinch the new growth back by about 1/3 its length. Also, remove any strong side shoot that outgrows the leader by pruning it back, leaving 1 to 2 inch stub. At the base of a stub, there are buds that will then begin to grow, and a new shoot is selected to replace the old growth. In subsequent years, remove any side branches above the main scaffolds that are more than 1/2 the diameter of the main leader with a stub cut. Once again, buds at the base of the stub will grow and form a new branch. Leave all the short fruiting wood. If necessary, only make an occasional thinning cut on a lateral branch on 2-year-old or older wood to make sure there is good light distribution throughout the tree. You do not want to make heading cuts near the tips of the lateral branches to shorten them. Instead, remove them clear back to the main trunk using the stub cut. To maintain a desired tree height, let the leader flop over with the weight of the fruit. Alternatively, the leader can be removed during the dormant pruning season to let a lateral branch become the new leader. The biggest mistakes with this system are to allow the side shoots to become too large in diameter and not renewing them, or trees become top-heavy and the narrow pyramidal form is lost. Again, For more detailed instruction, refer to our MU guide or the Penn State website listed before. Most apple cultivars require cross-pollination to produce fruit. For this reason, a different cultivar other than the main one is planted in the orchard. Here you can see two different ways to accomplish cross-pollination. The most efficient planting scheme is where the pollinizer trees are planted in a solid row between every 3 or 4 rows of the main cultivar. The shaded trees represent the pollinizer trees in these diagrams. The first method shown in the top figure makes it easier for harvest as pickers can simply pick the fruit in an entire row of trees. The second method is where a pollinizer tree is interspersed within the row about every 50 feet. When pollinizers are spaced in the orchard this way, it makes spraying a bit more difficult since not all cultivars are at the same stages of growth at the same time, and it also complicates harvest. One of the most critical practices is thinning the flowers and/or fruit to ensure a good balance of fruiting to vegetative growth. Thinning is done to prevent overloading trees with apples and to ensure a crop for the next year. If trees are not thinned, the weight of the fruit can break branches. Also, trees will produce excessive fruit one year, but very little the next, which is known as biennial bearing. Because insects can also hide in between fruit in a cluster, we try to thin to 1 or 2 apples per cluster. For the vertical axe system, I generally strip all the flowers off the tree in the second growing season and begin chemical thinning in the third season. Thinning with various products is tricky. If you don't remove enough fruit, you set the trees up for biennial bearing. But if you remove too much fruit, there is a loss of income. For this reason, chemical thinning is often used and followed by hand thinning to adjust the final crop load. Here I've listed the most common thinning products. NAD or Amethyn is applied from late bloom to petal fall and tends to drop fewer flowers than NAA. It is also best used near evening when there are slow drying conditions of the spray material. NAA is applied when the king fruit, which is the largest fruit in the middle of the cluster, is 11 to 13 millimeter in diameter and is best used at 70 to 75 degrees Fahrenheit under fast drying conditions. 7, which is also used as an insecticide, is applied from petal fall to 21 days later when the king fruit is larger than 13 millimeter diameter and is more effective than NAA. Maxell can be used when the king fruit is 5 to 15 millimeters, with only one application and when the temperature is expected to be 65 degrees for the following 2 to 3 days. Here you can see a tree that is overloaded with fruit with a lack of thinning. As soon as you see that there's inadequate thinning, remove additional fruit by hand. Different cultivars are harder to thin than others. For this reason, it's important to always read the product label for appropriate rates of application and refer to the Midwest Fruit Pest Management Guide, which can be found online for additional recommendations. In Missouri, growers tend to wait until after the danger of frost is past and fruit have set before applying a thinner. Also, it's important to know that products tend to remove more fruit under certain conditions, such as when the trees are not vigorous growers, when pruning was light, and there was poor pollination of flowers. Also, if there's high humidity during spraying with slow drying of the spray droplets or poor air drainage, more fruit will be dropped. It is also important to adjust the nozzles on your sprayer. To prevent too much spray dripping from upper limbs down onto lower ones, shut off the lower 1 or 2 nozzles on an air blast sprayer. Remember, the application rate varies with the apple cultivar, with Fuji being harder to thin than some of the other cultivars. Another important consideration is the use of irrigation. While we have plenty of precipitation annually, there are always periods of drought when trees need water. The most critical periods for moisture are during the first 3 years of establishment or when older trees are in bloom to 4 weeks after this, and just before harvest. Lack of water will reduce fruit yield and quality. There are extension guides available online to help design drip irrigation systems, which is used primarily in apple orchards in the Midwest. Also, NPR Supply is a company that does an excellent job designing irrigation systems for orchards. Soil and plant fertility is another factor in producing high fruit yields. A year before planting, take a soil test which can be submitted via your local extension office in Missouri for recommendations. Most soils in Missouri are deficient in phosphorus. If your soil is deficient in phosphorus, it needs to be incorporated at about a 12-inch soil depth before planting, because this nutrient is immobile in the soil. After planting, it's too late to apply this element, as very little of it will move into the root zone of apple trees. About a month after planting new trees, I generally recommend applying 1 ounce of actual nitrogen per tree to get them off to a good start. After this year, because there is a loss of plant nutrients as trees lose their leaves and when fruit is harvested, nutrients in those tissues need to be replenished annually. Before trees are fruited, we generally assess the amount of new shoot growth that occurred on the trees during the previous growing season. For example, for trees on an M7 rootstock, you would want about 12 to 18 inches of new growth per season when the trees are non-bearing, and about 6 to 12 inches when they are fruiting. During the early non-bearing years, apply about 1 ounce actual nitrogen per tree per the number of years of tree age. Once the trees begin to bear fruit, tissue analysis is used. To do this, collect 25 mid-shoot leaves from the outer canopy of several trees from mid-July to mid-August, keeping each cultivar rootstock combination as a separate sample. The test results are a measurement of nutrients present in the foliage, and recommendations are included when a nutrient is deficient. This is commonly done about every 2 to 3 years. When tissue analysis is not done, growers commonly apply about 75 to 100 pounds of nitrogen per acre annually on mature bearing trees. Nutrients are sufficient when found at certain percentages or contents in a foliar test. Here you can see the sufficiency ranges for each of the major nutrients: nitrogen, phosphorus, and potassium. When a nutrient is found to be deficient, only increase the amount of that nutrient that you applied last year by about 10%. Another important consideration is when growing Honeycrisp, a disorder called bitter pit can be problematic. Bitter pit is caused by a calcium deficiency. In New York, they recommend that Honeycrisp growers who had bitter pit reduce the amount of potassium they previously applied by 25% because excessive potassium can depress the amount of calcium in the fruit. Also, bitter pit tends to be more prevalent if nitrogen is high, crop load is light, and there is large fruit size. Unfortunately, sometimes tissue analysis results may indicate that there was a sufficient amount of calcium present in the leaves, but bitter pit still occurs on the fruit since it's another immobile nutrient. Also, bitter pit tends to be worse on the calyx end of the fruit. Previous research with Honeycrisp has shown that the amount of bitter pit was affected by the rootstock. Trees on G11 rootstock had the most bitter pit, while those on M9 or B9 had lower incidence of this disorder. Calcium applications are recommended for most cultivars at first, second, and third cover sprays, which we'll talk about more in the next session. However, for Honeycrisp, the first spray is generally when the first blooms appear on the trees. When bitter pit is problematic, 4 to 8 calcium sprays may be used. However, exercise caution as too many calcium sprays can reduce red color, which may make the fruit less appealing to buyers. Again, refer to the Midwest Fruit Pest Management Guide for further instruction. Another important nutrient is boron. External symptoms of boron deficiency are spots on the fruit surface. Symptoms in the flesh appear within 2 weeks after petal fall and up to 8 weeks after bloom. Later, internal breakdown of the fruit occurs and these apples ripen prematurely. A product called Solubor, applied at 2 pounds per acre at the pink flower stage and again at petal fall, is used when boron is low. When harvesting fruit, don't pick apples that have fallen to the ground, as they may be contaminated with animal feces. Also, fruit that has been on the ground for more than a day may be spoiled. Red or yellow-skinned apples should be well ripened with no green undercolor present on the peel. Underripe fruit has a starchy flavor that is undesirable. Immediately after harvest, fruit is refrigerated until it's washed and sorted into grades. Fruit sold as U.S. Extra Fancy or U.S. Fancy consists of mature, clean apples free of any imperfections. U.S. number 1 or utility apples have less color and may have minor surface blemishes such as russeting, limb rubs, insect stings, or other superficial scars, but are free of broken skins. Any of these grades may be used for cider, but lower grade fruit is sold at a lower price. Full descriptions of U.S. standards for apple grades are found at the site listed here. When embarking on this type of enterprise, it's imperative that you have buyers in place for your fruit. This concludes our first session on growing apples for hard cider. In the next session, we will address common diseases and pests that can be problematic when growing apples. I am happy to provide further information, and you can always contact your local extension office for additional assistance. Happy growing!